cover everything, but we will try to see the important concept. So today outline which we thinking can cover is like Azure Load Balancer, Azure Virtual Machine Scale Set, which is also related to the load balancer, and then Azure Traffic Manager, which is also kind of related to the Azure Load Balancer, and then Content Delivery Network, Autoscaling, which is a part of also a part of Azure Load Balancer, or it can work independently, Azure App Service. So what is Azure Load Balancer? So now you have been creating virtual machines, two virtual machines, and we have been talking about like in cloud things can scale. Any number of virtual machine it can create. Now the thing is that it can create any number of virtual machine, but how does it decide to when more traffic is there or more load is there, which virtual machine or server to use it, right? So this is a type of job which a load balancer does, which task is basically to balance the load, and so that high availability of your services or application is there. There are two types of load balancing in Azure. One is a public load balancer and one is an internal load balancer. So when the incoming internet traffic comes to the virtual machine, and if let's say traffic is coming from US, you are running let's say a google.com website, and if traffic is coming from US, let's say Netflix, you are running a Netflix, and traffic is coming from US, and traffic is coming from Norway, and traffic is coming from Germany. The load balancer can decide what is the server will be best suited to for the better performance. So anything which incoming internet traffic it tries to balance, that is a task of public load balancer. And it balances also when the across the virtual machine, means when you have multiple virtual machine internally. This I talk about the internet traffic coming, or later we will know internet traffic coming to a specific port number. So internally there are many your load of the computation, if it is a compute intensive task you are running. So internally if the load increases or decreases, so there is internal load balancer which try to balance the load between the virtual between many various virtual machine or your subscription. We will see with the figure how it is designed. And there are internet traffic can come which comes with a port number. So with the port number and with a specific destination IP address, or you can call it a specific virtual machine. So that also is a task of load balancer, that okay, this is coming from this port number, this is from this port number and going to this destination. Then from virtual machine which is already in your subscription, and if it wants to give connection, do connection outside, so outbound connectivity of virtual machine inside your virtual network is also be done by public load balancer. So we will see with the figure how they are. So if internet traffic coming, so internet traffic come HTTP comes with port number 80, right? So when traffic is coming, and this is a symbol of a load balancer, it's 3 arrow and 1 not an arrow. This kind of symbol is load balancer symbol. So when a traffic is coming, then public load balancer will decide which virtual machine it should give. And this virtual machine can be in a different region as well. So, but these are within your own virtual network. Now, when internally it has to decide to do a different kind of activity, this is a web related tasks, and internally there are business related tasks are there. So internal load balancing across virtual machines is done by the internal load balancer. There are many companies are there who create a product which has a job to do the load balancing only. In Azure, you can find many companies are there who has done a partnership with Azure, and they are selling their load balancing tools as a services to the Azure subscribers. Now, what are the feature of load balancer? So load balancer, how it understands? So it runs a hash-based algorithm. Hashing, you will be probably learning in your data structure and algorithm course or in other courses. So it runs a hash-based algorithm for distributing the inbound flows, and it also manages the flow to the backend pool instances accordingly. So by default, load balancer is going to use 5 tuple hash. Now, what are those 5 tuple hash? So in that, the first tuple will be source internet protocol address. Second will be source port. Third will be destination IP address. Fourth will be destination port. And fifth will be IP protocol, means what IP, TCP, IP, UDP, what kind of IP protocol it is going to use. So here, let's say is a web server which is trying to connect to your Azure various virtual machines. So there will be a load balancer. If this is a web server, then this load balancer is actually a public load balancer, which try to manages the traffic should go where. It should go to VM1 or to VM2 or to VM3. If all the VMs are equal or they are in the same place, so let's say if 50 connection comes and it has a task to manage the load. So what it is going to do, it is going to shift 20 connection to VM1, then 20 to VM2, and then 10 to VM3. This is how it is going to manage. And obviously, when it is shifting 20 to VM1, why not 23? It could do 23 or like 25 or 20. Why it is? I'm just giving an example that 20 it will send to here, 20 here, and 10 to here. It can be different, like 17, 17, 16 also it can do. So that can do the load balancing. So this is an example of public load balancer where it takes 5 information, which is called a hash, and depending on, remember we say that port, if it is a port forward and traffic is there with a specific port number, so it is going to know from this tuple that, okay, destination port is this and port number is this, destination IP address is this, so send this to this, and also it knows what protocol is there. Now, if there is this data is not given or not mentioned, then it can automatically decide by default which virtual machine things should go. So depending on the need, when you have many virtual machine internally, you want to connect, there are many services are there, and some services you can use simply a port number. If you are within a virtual network, then simple protocol one can use to do the communication, and then load balancer will not take a headache. What to do? Okay, I have been given a task, this destination, this port number, go. So what are the different services given by Microsoft for this, right? So if you want to see different services given by Microsoft, there are 2 kind of services given by Microsoft. First one is a basic. They call it SKU, which is a stock keeping unit, and then second is a standard. Basic SKU is actually free. Means when you are taking services, you by default can use the basic load balancer. So basic load balancer has certain feature. The standard SKU has certain feature, which is a chargeable one. So in a standard SKU type of load balancer services, one can create up to 1,000 instances for backend pool. But in a basic, 100 instances can be created. In basic, the virtual machine should be in a single availability set or single virtual machine scale set. But when you are paying the money, then you can have any virtual machine in a single virtual network, including the combination of virtual machine availability set, virtual machine scale set. And what are these virtual machine scale set and availability set? You will be learning either today or in the colloquium next week. In basic, only TCP and HTTP protocol wise, you can do the probing to know what is the health of virtual machine, whether your virtual machine is healthy, it is functioning or not functioning, if any problem happens. So TCP and HTTP only you can do in basic, but in standard service, you can also do HTTPS, which is a secure version of internet traffic. So what will happen if, let's say, you do the health probe and the load balancer observe the virtual machine is down or your services is down. In case of basic, the TCP connections stay alive when the probe is down. All the TCP connection will terminate when all the probes are down. Let's say I have 5 virtual machines and I created 5 instances to create the probe. And the moment it finds 5 of the virtual machine is down, all the TCP connection will be terminated. But in standard service, what feature it has, that TCP connection will stay alive and it will try to, by doing the connection, if any of the virtual machine recover itself from the services, then it is going to re-establish the connection. So the availability or the lag or delay will be very, very less. So this is an extra feature available for when someone is paying the fee. Then in standard zone redundant and cross zone load balancing, what is a zone redundant, your TA will tell you in the next colloquium or next to next colloquium, or I will be telling you next Friday lecture. But this service is not available in case of basic. Now, to understand the health probe and doing the load balancing or any kind of activity, maximum time in case of standard SKU is 30 seconds. But when it is a free service, it uses, it can take 60 to 90 or even more time to do a particular kind of, let's say you said, I want to create a virtual machine instance, then it might take 1.5 minutes to create it. But for standard, since the payment is given, they are using more faster processor and etc. hardware behind it, and that's how they are giving it a better service. So how it is charging? So if you think for standard, they charge based on the number of rules and the data it is processing inbound and outbound associated with the resources. So the rule of charges are simple. I am taking a standard SKU and the charge will be how many rules I am creating to different kind of tasks. Like rules, I mean to say a rule can be created. Let's say I have 3 virtual machines. I have said, okay, maximum 3 virtual machine I will like to do, and I want the automatic load balancing. And rule is that if 80% load reaches to a particular virtual machine, then start another virtual machine and balance the load. So this is a rule number 1. Now, if a rule is created, okay, if the load of if all the three virtual machines are running, or if load of any virtual machine goes below 50%, then shift the load from the another virtual machine to the one virtual machine and close that virtual machine so that you don't have to pay the money. So this type of rules can be created. But since basic services are non-chargeable, so some features are not available. And depending on business need, you can think about whether you need it or not need it. Usually, with a basic SKU, many companies can work around. If their tasks are becoming complex, or their business environment is becoming complex, they go for another service called standard SKU, and they can utilize. In fact, one can buy everything which Azure is offering, but if the employee in the company doesn't know how it can benefit the business, or whether it can benefit the business or not, no point in taking a service which actually we don't know how to use it. It's no point to have a gun if you don't know how to shoot it. So in the next colloquium, there are many tasks are there related to various kind of Azure services. One of this service, like how to balance virtual machine within one availability zone, like in the last week or in this week, you had done probably availability zone, and how to balance 2-3 virtual machine load across within one availability zone. If you go to this link, you can follow the steps and see how you can do it. And if you find any difficulty, you can ask questions to your team. So is that clear up to this? Load balancer clear? Okay.
Yes.
Great. Thank you. So next we move something like how, so when you go for creating the load balancing, then the concept of virtual machine skill set is there. And what are they? So they are actually, you can create a virtual machine skill set and by creating and managing a group of load balance virtual machines. So you can create a couple of virtual machines and you say they are the skill set. And while creating the load balancing services, the load balancer will decide between these virtual machine instances that whether I want to increase, let's say the logic says if it is more than 80% and it has to create another virtual machine, and you have said maximum load virtual machine is 3. So second virtual machine it is going to recruit, and automatically it can increase if load goes more than 80%. Now, if all the now the load in all, if you have maximum 3 virtual machine and the load in all the virtual machine is below 50%, so then the logic is there that you have set that if load goes below 50, then decrease the virtual machine. So this so what virtual machine to be decided by the load balancer, it is done by if you create a virtual machine skill set. So it helps in providing the high availability, means your system, your services will not be down, your application will not be down. So it can automatically manage and configure, and it also can help in updating the VMs. All those things a virtual machine skill set can help you. And using this service, a large scale service can be built up, which can do compute and big data analysis and manage various kind of workload via containers. So what are the containers we will be learning in the virtualization section. And also there will be a colloquium after next week or next week. So after 2 weeks, there will be colloquium on Docker or container. So So we're using this virtual machine skill set, the load balancing task or scaling up the businesses is possible more feasibly. Now next go to the Azure Traffic Manager. So there are various kind of traffics are there, right? This Azure Traffic Manager is basically the domain names system-based traffic load balancer. Regarding the Docker files, how to create Docker image, etc. The TAs are going to teach you, and then how to use the Docker to run a program. That will also be given to you. This can help you if some of you are going through the specialization in machine learning, etc. Then maybe it will be helpful for those programs. And also Docker is very commonly used nowadays in companies. My team also use Docker to do their research activity. So we have this central server, and on which using the Docker, we try to run our programs. So there are various activities are there. When colloquium comes, you can ask, and if more activity is needed, we can use another colloquium to do more activity related to Docker. So do not worry. Thank you for asking the question so that I can pass this information to TS. Now, Azure Traffic Manager is basically a domain name system based. That means when, let's say we are saying a Netflix.com, all the time I'm taking the example of Netflix. First of all, I also watch Netflix, and probably you also are using Netflix for your entertainment. So if we are using, let's say Netflix.com, and that .com has a domain name, right? But then if it sends, and the Netflix is having server many places to provide the services. Now, if traffic coming from Norway, it is going to send Netflix.com traffic to the server in the Norway or close to Norway, where the system can handle it fast and response can be fast. So Traffic Manager is going to distribute the traffic optimally across the various global Azure regions. So you have, remember, there are 52 and 658 Azure regions are there. So across this, Azure Traffic Manager can help. What it does, it helps in increasing the availability. That means response time of the website is good. And also, if one server is down, let's say you are accessing Netflix from Norway, and let's say the Norway server is undergoing maintenance at the moment you ask, then your traffic can be simply shifted to a server in Berlin or in Denmark or in Copenhagen. Any places it can be shifted. You might see a few 1-2 seconds of lag, but you won't feel like the server at the Norway is down. You won't be able to realize that. It improves the performance of the application. Like response is going to be fast, and the latency felt by the client will be low. Now, before this cloud was there, when we used to access different websites, the server is down used to be the common phenomena. In fact, currently, many government organizations who are still maintaining their in-house server, they are for various reasons. There you may still find that server is down kind of issue, but the services which are running on the cloud, we don't see at all. Almost rarely we see you are not able to reach the website or something. So as I also said that you can do the maintenance without a downtime. Like you have server, if you are running the any kind of hardware infrastructure, the maintenance is required. Maintenance like software upgrade or various kind of maintenance will be required for every hardware we are using it. Now, whenever earlier when you have to do the maintenance, that time we have to display, okay, we are undergoing maintenance. Nowadays, bank also most of the time they do at night the maintenance, and they say the portal, the login portal for your personal account access is not available. But using, because of this Azure Traffic Manager, and you have created multiple regions, taking the services of multiple regions, then if one region having a maintenance, the traffic can be diverted to the other region. The algorithms are there which will automatically do it. So as again, highlighting it, Traffic Manager only works at the DNS level. That means it works with the web traffic. Now, there are various kind of algorithms are there by which traffic manager route the traffic to a particular server to another server, or traffic coming from a particular type of region. So there are priority-based traffic where you can tell, okay, this endpoints means this virtual machine I am giving a priority, or this is a primary or a backup endpoints. If the primary and backup endpoints are not available, then go to shift this traffic to this particular endpoints. So that is a priority base. Now weighted. So when you are creating the VM, and you can set the priority, and the weights you can set like 1 to 1000. And this kind of interview question can be asked if someone is very tricky to ask the question that traffic management on the cloud, and you are using priority. What is the priority, maximum priority you can set, or a range of the priority you can set? So weighted priorities are from 1 to 1000. So higher the number, that is going to have the higher priority. Let's say I have 5 virtual machine, and my priority set for first virtual machine is 50, second is 90, third is 150, fourth is 200, and fifth is 999. So the priority, whenever a traffic will come, the fifth virtual machine, which has a priority 999, the traffic will go there. Now, the third is kind of approach is performance based. So I don't worry. So this particular say that give access to the closest endpoint as per the network latency. So it doesn't say that geographic distance means if I'm accessing Netflix from Tromsø, my server might be in Oslo. So, but if the server is having more traffic, and the time it is going to take is longer to get me from Oslo, then it can switch to the closest another server where the latency is smaller. So how it comes to know? So Azure load balancer, the traffic based load balancer, keep a lookup table all the time. What is the latency between one region to another region? So this kind of lookup table is there. So if it observe that a particular traffic area or server region traffic is more latency, it will have a record that it is taking, let's say, 40 millisecond. And if the server in Berlin is taking 35 millisecond, then it will route the traffic to Berlin. So, and in fact, if you ask me what is the used, so in industry, this performance-based traffic routing method is the most used preferred method, and most people choose this performance. Because when we are going for cloud, and what if there are no legal compliance or things like I don't want my data or anything to go outside my region, then people don't worry about. They say I want performance, give me my performance. So then another method can be the geographic distance based, where you can define that this particular from where the query will originate, and then based on that, the traffic will go to the server in that particular region. In fact, we can also define, okay, we do not want traffic. My services is not for, let's say, one particular country. And then if the incoming traffic is coming from that particular country, then we can set that no, do not allow, or put my traffic only to this particular region. Then there can be a multi-value traffic routing method where it will maintain multiple healthy endpoints, means multiple VM servers which are healthy. So in case any traffic is coming, and while the time, if any of them is not working, it can simply switch the traffic to the next available healthy endpoint. So this is also one of the preferred method apart from performance. Then the subnet-based traffic, where you set end IP address. I want my traffic to go only to this IP address and this port number or that. So these are the 6 approaches are there. So far this is okay.
Yes.
Thank you. Now CDN is a very important concept. Means if you ask, there was a network outage was there on 8th June 2021 this year. A couple of news company network, the website was not responsive. So what is a CDN? So if you think CDN, what is that? Like if one user asking, I want this particular page access, let's say Netflix, and if let's say, I'm just taking an example, this is not a right example. Let's say I'm asking for a particular bbc.com, an article on Afghan Taliban takeover to Kabul airport. This is a recent news. So it is asking bbc.com that particular page. So there are edge servers are there. Now, what are the edge server? As you know that Azure has 58 region, and Amazon Web Service, I think it has a 20 or 30 region. I forgot the actual number. So now this 58 region, but they are serving more than 150 countries. How they are managing so responses? So the places where they do not have a region, they keep an edge server. What it does, so if whenever you are asking for a particular page, then it first look into the cache in the edge server, and if the page is available, it is simply returned back. But now if that page is not available in the edge server, that is the page first time access, then it is going to go to that domain name actual server where the BBC and report on Kabul, that particular news is there. Then it is going to return to the edge server, and edge server is going to keep record of those page in their cache, and it is going to give it to the user. Now, if the same page is requested by another user in some region or other region, then it will again look to the whether the page is available in that edge server or in the caching, and if it is available, then it will simply give back. So now, how long it is going to keep the record? So by default, 7 days. So that's how you see whenever you access certain page, if that page is accessed within last 7 days, you will get immediate response. If it is not, then it takes some time to go to the actual server. And this is how the content delivery of the web content is delivered, and we are getting a very fast web access and web response because of this content delivery network. So CDNs are basically endpoints. There are many endpoints globally distributed. There are many companies who actually provide the CDN services. So they keep various endpoints at various places. So one of the company which actually, because of that, this 8th June 2021, the blackout of certain news channels happened was because of there is a company called Fastly or something. There was a software bug which was there, and the user, the programmer who programmed it, because of his technical less knowledge, that bug was still there and it was not been tested, and because of that bug, the network blackout was there for more than 45 or minute or to some few hours. And that particular company was providing services to 500 and more content-based companies. And there was a big news. Now, data from Azure storage is cached at the CDN endpoints, and user data from the closest content delivery endpoint are used to minimize the latency. But don't worry, it does not store all the information. It only stores the publicly available data. Means if I am accessing my Gmail account and user ID and password, now Gmail account, that page, my user ID and password page is not a public, so the CDN doesn't store that. Any page which is publicly available without user ID or password, or without any user ID and password, those are being put in the caching. And if data is not available, then as I said, it is going to help retrieving from the origin, and then the caching is done at the particular CDN endpoint. We can also use Azure CDN to restrict the access from certain country, and like my content, if it is objectionable by certain country, or certain country laws can be applicable to me if I put that content, so we can restrict that, okay, this particular country will not have an access. So anytime when the access request to a particular page is made from that country, then my CDN service will not give any feedback to it. It is not going to provide that page. As I said, the default 7 days. So if you go to HTML page source code, some places you might see a TTL time, might be set default, or might be set 1 day or 2 day or certain minutes. So depending on, maximum is actually 7 days. You cannot store more. No, you can store more than 7 days, but default is 7 days. So, and you can set 1 day also. So after 1 day, it won't keep in the cache. There are a lot of pages are coming. So it also maintains the performance by compressing the data. As you see in the WhatsApp, when you send any kind of video file or image file, it actually compresses the data so that a fast delivery they can do. There are other services like Telegram. You can send the data without compressing. I think in WhatsApp, they are now added a feature you can send data without asking them to compress. You can send as it is. So CDN also shares the cache, it shares the cache. It is a shared cache. And there are, in CDN, there are various kind of limits are there. Like we can create 25 CDN profile in one subscription, and maximum limit, default is 25, maximum is 25. So I have one subscription, I can create 25 CDN profile. And in each subscription, I can create 10 endpoints by default, but maximum 25. So like 25 into 25, 625 CDN profile can be created, because that many endpoints are there. And the custom domain endpoints are also default is 10 and maximum is 25. So if you do any tutorial from Microsoft Azure on CDN, you can explore this option. This won't be you done in the colloquium. You can try by yourself. Now, Azure Autoscaling. Now, Azure, where every cloud service provider provide the autoscaling, means you can scale, the services can scale, define what number of services or what number of resources we have said that this is a maximum limit. Up to that, the Azure can automatically create that many virtual machine or that many network services or storage. So it helps to add resources which can handle if the load increases. Like nowadays, startups are happening and they are just happening from their initial stage and initial cost of using the cloud. They might be using €1,000. That should be okay for a startup, but as if they start becoming a viral and immediately they need more resources, and that time they can simply change their configuration and can scale up. You can specify minimum and maximum number of instances to run. Now, if you say minimum 2 and maximum 2, then basically we are not taking any use of auto scaling. So if you are saying minimum 1 and maximum 2, then we are taking the concept of auto scaling. We can also set maximum 10, minimum 2, or minimum 1, but one services has to be there. So having a minimum makes sure your application is always running even when there is no load. And in auto scaling, there are two types of auto scaling. Like we can increase or decrease the number of VMs. So we have one VM, we can add more VM of same type. So that is called horizontally we are scaling. Or there is a vertical scaling where we can increase the capacity or power of virtual machine. Like, okay, I was using this gigahertz, this CPU virtual machine. I want more core virtual machine and more RAM space virtual machine. So that is called vertical scaling. It does allow you. But in virtual scaling, the virtual machine has to stop and restart because you understand that we are actually increasing the configuration. So this virtual machine has to stop. A new virtual machine will be created. This load has to be transferred to the newly created virtual machine, which has a maximum bigger load. Currently, the virtual machine automatically cannot scale in the CPU configuration or capacity configuration. It has to be stopped and then the load has to be transferred to the new one. So we are not able to cover the app services. That will be do it next Friday.